What's up, guys? Kyle Milan here with another episode of Manufacturing Tribe TV. Today we are in Everett, Washington at SEA-LECT Plastics. SEA-LECT Plastics is a custom injection molder. Now this is pretty cool for me because I spent about a decade in the industry. For those of you who don't know it, out of all the different types of molding and plastics, injection molding represents about 50 to 60% of the plastic parts that you see have been injection molded. So this is going to be cool to see some stuff here, everything from musical instruments to parts for kayaks and everything in between. We're going to see some cool stuff, so stick around.
I spent 15 years in the manufacturing world, and now I'm on a mission to show people how things are made and excite the youthful generations to get them involved in this amazing industry. This is Manufacturing Tribe TV.
What's up, guys? I'm here with Matt Poishbeg of SEA-LECT Plastics, who is a custom injection molding company. And right now we're standing in a tool room, which isn't extremely common for a custom molder to have a tool room of this size and these capabilities. So Matt, explain to me what we have over here.
Well, we have basically 10,000 square feet of machining space, because for injection molding you have the necessary evil, the injection mold. And we have one right here, for example. From the outside, it doesn't look like much. It looks like a chunk of steel,
right.
But it basically includes a lot of time of labor hours. This probably has like 40 to 50 labor hours of a skilled mold maker working on this. And when you open it up, that's when you see all the intricacies. And the equipment you see here is pretty much everything you need to build molds from scratch, from computer files, obviously, but we could build it from scratch, from a sketch on a napkin. We have grinders, we have manual mills, and we have the Haas CNC milling machine, and we just got in the ProtoTrack CNC, which is actually not hooked up yet because it came in on Monday. And we have 4 guys working here. We have Rob, who's our principal mold maker. He's been in the industry for 40 years, started out in right after high school actually, went into an apprenticeship program, and is now the mentor for our 3 apprentices who are working here at SEA-LECT Plastics.
Okay, so you guys have apprentices. Do you guys have an apprenticeship program here, or how does that work?
Basically, 6 years ago, or let me back up. We started in '87, okay. And back then we already had a tool and die shop, but we had 4 full-blown mold makers working for us. And we built every single mold we were running in our production shop in-house. Over the years, all those mold makers pretty much retired, and eventually I had no way to replacing them because that mold making skill, which is an apprenticeship, was not fed with new young guys or girls who wanted to learn that trade, because most of our production or manufacturing business went offshore. Right. And so finally 6 years ago, our last principal mold maker, so to speak, wanted to retire, and I advertised locally, nationally. I got a headhunter involved, and I just could not find a person to replace him. That's when I thought, okay, I'm from Germany, I went through apprenticeships, why don't we just do it here? So I called the Department of Labor and Industry, which oversees our apprenticeships here in the state of Washington, because they have to be registered. You know, you get a German card, I mean, it carries a weight. Yes. And so they told me, well, you know, you don't want to necessarily do that on your own. Why don't you talk to AJAC? AJAC is the Aerospace Joint Apprenticeship Committee. Started a long time ago for aerospace, but didn't just focus on aerospace, but also advanced manufacturing. I called AJAC. Sure enough, they had a tool and die maker apprenticeship program. I then needed to find an apprentice, which so happened to be somebody who just knocked at the door and was looking for a job. And we were basically on the road of getting back into the mold making business. And so now we have 3 apprentices. We have one in his 4th year. He is in the late 20s. And then we have 2 who, one is Nathan. You'll meet him later. He started right out of high school, is in his 2nd year now, and has just finished his 2nd mold, which is, to me, super exciting.
Yeah.
And then we have Bradley, who actually started at 17 as a youth apprentice, meaning he was still in high school while he started his apprenticeship, and is now here becoming a mold maker.
So one thing in that story that I think the audience needs to see is that that's where, like, a lot of people, when you run into these problems where you couldn't find the skilled labor, a lot of people would just throw their hands up. But Matt went down the path of saying, I'm going to create an entire apprenticeship program to keep this going, which is just great. I mean, the show is all about getting the youth involved and getting the next generations in. You've experienced that problem from the get-go with the tool and die shop, and going down that path of apprenticeship is innovative, and it's not something a lot of people would do, to just create your own in conjunction with Ajax. So that's great to hear. All right, Matt, walk me through the equipment that you guys have here. So I see that you guys have a lathe, right?
So we have basically 2 manual lathes, which whatever we do, we don't do for production. A mold is made out of a puzzle piece of different metal pieces, so to speak, but most of the time there's maybe one of those metal pieces in that mold. So we can easily use a manual lathe, even if it's a little bit older, but we only make a few pieces out of it, so to speak, because we're not cranking them out.
So you guys might have seen in episode 1, we were at a CNC machine shop in South Austin. This is similar type of equipment, but at that machine shop in South Austin, that's all that they did. So they're turning and burning production parts, high volume, highly detailed and engineered. But here they're just using this as an aspect of the equipment, as an aspect of them to run production through these molds. So this is more maintenance, upkeep, design changes, things like that. So we're gonna go through the rest of the equipment. So next, what do we have here?
Next, we have our brand new ProtoTrack machine, which basically is not even unwrapped. It just arrived on Monday, and we talked about the apprenticeships earlier, and that's when I really get excited about this, because a few years ago we didn't have CNC machines or computer-controlled machines, because you need certain skills to program them, and the usually older, high-qualified mold makers did not necessarily make the connection to the modern technology. So they could build you anything by hand, but not necessarily program everything on the computer. And that's where Ajax and the apprenticeship came in, because the apprentices go to school 4 hours a week, and that's actually where they learn to run these machines. So that was one thing when we hired our first apprentice. He said, okay, I want to do CNC stuff. I want to be on the computer. And we said, okay, once you get the skills, once you get there, I promise you, we buy you the machine. And that's exactly what we did. We bought that Haas when he was ready, because of his classroom training, to take that on. And so now we have 3 apprentices, and basically 2 of them are already building molds here. So we are running out of machine space. So we decided, hey, the guys are ready for it. Let's make the investment, and our goal eventually is to build 50% of all the injection molds we need for our customers here in Everett, which to me that's that's my dream. I mean, it's going to take us a few years, but we'll get there.
Yeah, so staying committed to that apprenticeship program, investing in the equipment for these young guys to get their hands dirty and make some stuff.
Right.
What is this Haas doing over here?
We got the Haas, the VF2, and so, cutting out a pocket, you can do by hand, or drilling a hole, you can do by hand. You don't need a machine for that. But repetitiveness, and contours, doing that by hand is possible, but it's very, very time consuming. And in these day and ages where we have to be competitive, we need technology like this.
Yep. High speed. All right, last piece of equipment, Matt, what do we have over here?
Over here, we have a very old, but still functional EDM, electric discharge machine.
Okay.
So in mold making, pretty much everything is mirrored. Everything is the opposite of what the part is going to look like, because that's the pattern, so to speak. A lot of times you're dealing with radiuses and corners and stuff like that. A milling machine, everything you mill, pretty much, if you go into a pocket, you will have a radius of some sort. You can't just go in a 90-degree angle. It's impossible. But sometimes on a part, you need that 90-degree angle. You need a certain feature which you can't mill with the milling machine. So you take the milling machine and you machine the electrode, which is the positive pattern of that cavity, so to speak. The electrode then goes into this machine, which the electrode is usually made out of copper or graphite. And in this machine, with the conducting fluid, the electrode literally starts eroding metal wherever the electrode hits the metal or closes onto the metal by sending an arc down and a current.
So it's burning it into place, into the steel.
That's kind of the slang. Yeah, we're burning something.
Yeah. So this is the starting point with the kind of the process, building a tool or maintaining a tool, and then it goes into production. So where does it go from here? Let's go to that point.
Sure. Let's walk this way.
All right, Matt, so it looks like you guys have a mold up here on a computer. Are you doing some design work here?
Yes. So basically, like I said earlier, for every mold, there's going to be a mold design. It used to be in 2D, it used to be all big prints. Now it's all in 3D, and it's basically, we use SolidWorks, and so it's basically just a solid model which has every single detail, every single pin, every ejector pin, every slide in the exact dimension as it has to be built. And you probably know that plastic has a shrink rate, right? Every single plastic shrinks differently. And so the shrink rate is built in this mold already. So these dimensions we take off or bring over into CAM basically are the dimensions we are machining to. And then here we talked about electrodes earlier. So here's just a cool electrode which basically shows you that.
So this is the electrode, and then when that's charged, it's burning into,
Correct.
This is the burning part, burning into that part.
Yes.
Yep.
Yep.
All right, so we're out here on the production floor. This is, I know this, very familiar, IQMS real-time monitoring. So explain to the people at home, what is this system and what is it doing?
Okay, IQMS, maybe it sounds cheesy, but it's every molder's dream come true. I mean, it's an enterprise resource planning system, so it runs our whole company, so to speak. And when we implement it, we didn't try to bend the software to the way we were doing things. We actually adjusted our way of doing things to the software so that we would be able to get the most benefit out of the package, so to speak. But you know, injection molding has a lot of different variances. It has material, it has machine, it has labor, it has lead times, it has shipping, and you name it. It has all those different variances, maybe more so than generally speaking manufacturing. And so IQMS is developed, or has been developed specifically for injection molders. And what we're looking at right now is our production screen, so to speak. It shows you what every machine is doing because all of our molding machines are tied into the computer system in real time.
You as the GM are able to come out here, you can quickly glance at this screen and just from the color coding see what's running the cycle, what's down, what are you waiting for. So it's a nice visual, visual tool for you to quickly look at it without having going machine to machine. Perfect.
Other pieces of information which we look at constantly, which is updated constantly, which is really helping us to run this very smoothly.
So Matt, you guys have 16 machines here, 33 tons to 600 tons. Here's the smaller ones. We'll start walking down the line. It looks like you guys have a mix of hydraulic and some of the hybrid machines. Talk to me about the differences between the two.
Maybe I can just back up and talk about the tonnage.
Okay.
Because molding machines are generally speaking rated by the tonnage. And the tonnage is basically the tonnage of keeping the two mold halves closed.
Right, how much force?
Exactly. So you're injecting plastic at one side, so you have to have something on the other side to keep that mold closed.
Yeah.
And so the smaller plastic injected at once, the less tonnage. And so that's why there's the smaller machine here going up to the larger machines over there.
And so then some other rule of thumb that I've always talked about would be, you know, a 33 ton can make a part, let's say this big. A 600 ton can make a part, let's say 2 feet by 2 feet, right?
Right.
Roughly speaking.
Right.
So that way you have a nice range of 33 tons are for smaller parts, 600 tons about 2 feet by 2 feet.
Right.
So I see some hydraulic machines here, and then it looks like you guys have some hybrids.
Yeah, for instance, as you probably noticed, we have all Cincinnati Millicron machines.
Yep.
And so we choose Millicron a few years ago because we just like service. We have a maintenance tech, but these machines change all the time. So to have a machine manufacturer who gives you customer service and machine service is very important to us.
Yeah.
And that's what Millicron does basically.
So service is important to you. I see that you've got one of the newer lines of the Millicron machines, right, with this Magna?
Yeah, so they're called the MTS, the Millicron MTS. And when Millicron came out with these, that's when we really got excited because the hybrid means that they're on basically a hydraulic molding machine. You have a big electric motor which runs your hydraulic pump, which then pushes the hydraulic fluid through your valves to operate the different parts of the molding machine. Well, in the older days, you had a humongous electric motor which was basically running at idle high speed and was producing a lot of dirty power, so to speak, because it was not using the electricity to move something. With the newer machines, the hybrid machines, you have also still an electric motor which runs the pump, but the motor is a variable speed drive motor. So it idles at a very low RPM. And then when the machine signals it needs oil, the pump has to move, then it speeds up real quick, does the job, and then slows down. So it's basically a 40% savings in electricity.
Which is huge when you look at a plant like this. I mean, that's tens of thousands of dollars sometimes a month.
I mean, our electric bill in a year is $100,000. So whatever we can save, it pays for itself.
Yep.
And so we replace the older equipment with the newer equipment. The other cool thing is every injection molding machine needs heater bands around the injection molding barrel to get that plastic to a starting temperature, so to speak. And so we have these new TCS Rex heater bands, which are more like a radiator. They are not releasing the heat into the atmosphere, into the shop. They're just concentrating the heat going down into the barrel, which again gives us better control on our heats as we're doing the process dial-in, but also reducing power again because we're not heating the shop with our molding machines.
Right. Yeah, so what Matt's talking about here is that the traditional way of doing it is that you've got this barrel, which is a cylinder, and you've got heater bands that are touching it, whereas these TCSs basically clamshell around it with space in between touching the barrel using radiated heat, and most of the time you can't touch the top of the barrel, but with these you can. They're completely safe to touch, and there's no heat dissipating off of the top, which in the summertime is going to heat up this place real quick, and it's going to be really hot. Yeah. So great to see that you guys, I mean, more energy savings for you.
Yes.
Awesome.
Yeah.
All right, so let's go down and look at the bigger machines, and you've got a particular part to show us here, right?
Yes, I really wanted to show you guys the ukuleles we're making because I think that's kind of a unique thing that you make musical instruments, not just toys, but the real deal. And so this is the bottom of a outdoor ukulele. The customer is basically, the customer is called Outdoor Ukulele.
Okay.
And he invented this instrument because people would like to take they are guitars or they're ukuleles, camping, hiking, backpacking, kayaking, boating, and stuff like that. But a wood instrument, you know, it
in that environment would be great.
destroy.
I've never seen a plastic ukulele before, so this is very cool.
Yeah, so if I can show you some instruments.
So this is the finished parts?
So this is, he has two sizes. One is this size, which is also the black bottoms you see, and it's the tenor. It has a different sound. Okay. Unfortunately, I can't play. Maybe you can.
No, I can't. I can play a guitar a little bit, but not a ukulele.
And then he has the soprano, which is just another size. It sounds
like a higher
differently,
pitch, yeah.
right? And then he has, and this is out of glass-filled polycarbonate.
Okay.
So then he wanted some different acoustics and even more higher impact strength, and he asked us to use carbon fiber. So this one here is actually a carbon fiber bottom, and the loading is about 10%.
Okay.
And when he played on this ukulele for the first time, he was just like, oh my God,
really?
It sounds so good. He was just super happy about it.
Awesome.
And you had asked me earlier, you know, what is the difference between Select and other molders, and maybe this is a good example because this customer went through, I believe, 3 different molders before they came to us, and this product is not very easy to manufacture. It has a lot of variances, and it took us a lot of time to figure out these variances. And to be honest, we are still learning every single time.
Yeah.
But we are willing to take the time. We are willing to work with the customer and go the extra step, I guess. Get that extra batch of sample material. Get that extra batch of sample color. Try this new carbon fill. Try this new bioplastic.
Right.
Because customer here is number one. We wouldn't be here, SEA-LECT Plastics would not exist without our customer. And I think that goes through the culture of all of our employees, that they know customer is number one. And in this case, we really solved this puzzle by figuring out how to make these and how to put them together, because you have a bottom and then you have a top. You have a top, and the top has to be just fit perfectly onto the bottom. Okay. If it's not perfect, our customer is a perfectionist.
Yeah.
If it's not perfect, it's no good.
Yeah.
And that relates to the shrink rate of this material, which drives the fit. And so we figured out there's just a % of difference in carbon filler or glass filler makes a difference in the fit.
Wow.
It's just that close.
Wow, very cool.
Yeah.
All right, Matt, so it looks like you're doing some final assembly work over here.
Yeah, so this is just a work cell we have set up for this very specific product. We're making a fishing rod holder for one of our customers. It's Lifetime. Okay. So Lifetime puts them on kayaks. And so we do a decent volume on these, and instead of just putting everything in boxes, putting it in the warehouse, then pulling it all back out of the boxes, and then assembling it as a totally second step, we integrated it in the production floor. Okay. So parts are being made over at the molding machine as we just walked by. They are basically getting routed down here in bins, and then Logan takes them out of those bins, puts them together, puts them in these boxes. He has a scale right here, weighs the box, makes sure that it's the right quantity, and goes on a pallet. Pallet gets shrink wrapped, out the door. So we're basically reducing the amount of touching the individual components.
So you got ukuleles, fishing rod holders. What are some other things that you guys are doing?
I had a kayak here because we are doing a lot of things for kayaks. So, for example, the rod holder, which is being assembled. There you go. That's what it is on the kayak.
So you're not going to make the kayak because that's probably blow molded or something, right?
That is exactly right.
So you guys are making components for these kayaks.
Correct. And our famed product, more or less, is our kayak foot brace. That kind of got us into the industry about 17 years ago. We have several versions of the foot brace, and it's patented and stuff. And this, for example, is the version for rudder control. So the idea behind it is that you're sitting on a kayak, you need to put your feet somewhere, and not everybody has the same length legs.
Yeah.
So you need to have a pedal which is adjustable. And what was on the market was just not good enough, and so we collaborated with kayak manufacturers and came up with this foot brace. This one is for rudder control, so you have a pivoting paddle which drives actually the rudder, which looks like this, and it has a retractable blade.
Okay.
So when you're not using it, you can basically pull it up.
So it's helping you to steer, so you can steer with your feet, controlling the rudder.
Correct.
Right.
Steer or track, basically keep your kayak on a course.
Right.
Versus currents and winds and all that good stuff.
Yep.
So all these parts are made here except the metal components. All these parts we developed on our own, did the design work as we saw, and built the molds for it. The molds, however, we did not build in-house.
Okay.
We didn't have that capability yet.
So what do you guys have on the table? Looks like some more. So we see the ukulele, and you got a banjo up here too?
Yes. Just quickly on this one, I think I told you when we talked about bioplastics and stuff like
Yep.
that. There's this plastic made out of greenhouse gas.
Yeah.
So they take the CO2 out of the air, they convert it into sugar, and then the sugar into plastic.
Wow.
And when I read about that, I mean I was just amazed. So I wanted to try it, and so I told my customer, the ukulele customer, you know, hey, can we do that? Can we do compostable ukulele, so to speak? But unfortunately, it did not work for the ukulele because it's not stiff enough.
Okay. But still, a valiant effort at trying something different, you know?
So then I just have a few parts I wanted to show you. We do quite a bit of mold tests for some local companies. We have Fluke, you know, they do these testing devices and stuff like that.
Multimeters.
Multimeters.
Yep.
So we do some mold tests for them.
Yep.
Again, we do a large variety of all different sizes and kayak hatches, where you usually have a rubber on the outside, and then you have a hard lid and a hard handle.
Yep.
This was a project which, again, our customer came to us and had no success with other molders he normally works with, and we could pull it off. This is not that difficult. It can be ejected out of the mold, but this one here, once it's molded, you actually have to turn it to get it out of the mold.
Wow.
Yeah, so not everybody's cup of tea,
Yeah.
but we could pull this off. It's also for a kayak paddle drive, and that's why this propeller is here. This is not for an airplane. It's actually a 40% glass-filled, a long glass-filled polyurethane propeller for kayaks.
Okay.
Just some examples for insert molding. You know, these are some fuse blocks. Here, another cool part for you know, where you overmold a polycarbonate on a machine aluminum piece.
Yep. Very cool.
Some more foot braces. We have one customer who has a lot of different carriers for pneumatic tubing systems, banks, hospitals, warehouses, and stuff like that. You know, you can open it up, you can put stuff inside, and you shoot it through. Hold back both.
So anybody that's ever been to a bank, you've seen this when you go through the teller.
Yeah.
That's very cool.
And then we have one customer which does all kinds of different tripods for photography, for military.
Yeah. It looks like you got some, what are these, tumblers?
Some cool tumblers.
Yep.
And basically some more cool plastic. This is a wood composite. So our supplier takes recycled wood and compounds that together with a compostable plastic made out of corn. So you can put that into the ground, or you can put it in a composting process. It disappears. Hemp fibers. Would you ever think you can put hemp fibers in plastic?
Yeah.
Yeah.
I mean, they put it in clothes for years, right?
Right.
But yeah, that makes sense.
So here you go.
Yeah.
It's just,
Very cool.
it's just something we tested because I'm just, you know, it's just, I love to use this stuff at some point in time for an application. I don't have an application yet, but
Well, you're like a mad scientist trying to just figure out new things to do.
yeah, exactly.
That's great.
My name is Nathan. I work at SEA-LECT Plastics. I've been here for 2 years. I'm a tool and die apprentice. So during high school, I got started doing manufacturing. We had a class called Fabrication Lab, and we ended up making like miniature molds, that sort of deal, snowboards and all that. And my shop teacher introduced me to Matt, and so we went off, took a tour here, and Matt offered me a job, and so I got started.
My name's Ronnie Bowers. I'm lead processor here at SEA-LECT Plastics, and I've been here for 10 years. Just saw the job opportunity, and I started as an operator running the machines, and then just moved up through there.
I'm Amber Glenn. I'm the shipping, receiving, and inventory control lead, and I've been here for 3 years at SEA-LECT Plastics. I got started when another company was shutting down. A previous coworker of mine happened to be working here and liked it, so I talked with Matt. I started out a long time ago as an operator and just worked my way up. I have a lot of skills in other places, so it's worked really well for me to kind of be put in where I'm needed.
how I got started in this industry is kind of by accident. In Germany, apprenticeships, for example, are the backbone of the economy. Came to the city of Everett for my internship. Loved it. CDOC said if I can figure out how to get a work permit, they would hire me full time. My boss liked me so much that he said, well, Matt, it looks like whatever you do, you're taking everything seriously and you're doing a good job. How about running SEA-LECT Plastics? I thought he's joking, that I basically have all the foundation for my skills to do this by learning from my coworkers and mentors. When I started here, I didn't know anything about mold making, didn't know anything about injection molding, but I had employees, coworkers who knew exactly that, and they taught me everything I know pretty much.
The career opportunities with tool and die is almost endless. Anywhere in the world you go, you gotta make a whole bunch of cool things. You gotta learn because you gotta meet a lot of cool people, travel around the country. You get to do some really challenging things.
Coming in and starting as an operator, you have an option of going to the roof if you like. There's always some new mold coming in that you gotta try and figure out how to process that plastic right.
Because it's always busy. There's always something to do, something going on, and it's very fast-paced.
What I love about my job is that my job doesn't get old. It doesn't get routine. I have basically a new project or several new projects I have to deal with every single day.
Get into this industry as soon as possible. It's definitely worth it.
Finding qualified employees has been difficult for all the 24 years I'm working here. 7 years ago, we started to train our own employees, to train our own professionals through apprenticeships. At this company, we need workers with skills, but we don't need college degrees. In school, the kids are so many times just fed information, and they really don't know what they're going to do with that information. What they should do when they are in school, they should think, okay, what kind of problems do I want to solve in my life, and what kind of knowledge do I need to solve these problems? Then they can ask the teachers, and the teachers becoming more a mentor than just a person who feeds information.
Matt, thanks so much for showing me all the cool stuff you guys are doing here at SEA-LECT Plastics, from the banjo to the ukulele to the kayak equipment. I really appreciate it.
Thank you, Kyle. Thanks for coming out. I appreciate that very much.
No problem. Hope you guys like the content and everything we showed you at SEA-LECT Plastics with custom injection molding. If you like this, share it with one person, hit that subscribe button, and we'll see you on the next one.